Hi, everybody. All right, today we're going to go ahead and I'm going to go over some of the instructions or some of the background on the dot product and work. So dot product, all this vector stuff is totally new to us. But it's kind of fun. I like dot product. I like working with these ideas of vectors. So let's go ahead. Let's get into the three different types of dot products that we might be using throughout our assignment instructions in this unit. So first off, let me give you some vectors, some u and v. And so I'm going to say that my vector u is going to be u1, u2. My v is going to be v1, v2. So when I talk about it, dot product algebraically, so define the dot product algebraically, it's going to be u dot v. So again, this is when we're taking it from component form. And that's going to equal u1 times v1 plus u2 times v2. So I'm going to take both of the ones, multiply them together, and I'm going to add it to both of the twos, multiply together. That's it, done. The next one's going to be geometrically. And of course, I'll show you guys an example of that. And so if we talk about it geometrically, it's going to be my u dot v would be equal to the magnitude of u, so notation, the straight lines up, we're taking the magnitude of the vector, times the magnitude of v times my cosine of theta. So some angle measurement that we need to figure out there. All right, and then projection. So dot product using projection. This is probably the hardest of them. What this is saying is that if I have my dot product, so I have A projected onto B, is what this notation means. This piece right here, let me highlight this. This right here is this. That's what that represents, is that. So this A with the little sub B, it's A projected onto B. That is this whole magnitude of A cosine of theta. So if I was doing this piece, then I would be using, if I wanted to be onto A, I would be using the magnitude of B here. So that would be the two differences. Just depends on what you're given. Something very important that I want to point out is that the output, the solution for a dot product is always a scalar quantity. It's always going to be a single real number. It's always going to be a real number. It's going to give you some type of real number. So I'm taking these values here and it's going to give you a number like 2, negative 25.7, whatever it might be. It's going to give you some type of real number. It's always going to work out that way. Okay, so how do I know which one of these three to use? Well, it depends on the information given. So look, I'm given two vectors here. If I know the two vectors, I can easily just use my algebraic option. So this first example right here, this would be algebraic. If I look here, I have the length of two vectors, Well, lengths, remember, lengths is just the magnitude, right? So I have the lengths is equal to negative 20. What is true about the vectors? Okay, so I'm looking here and I know it has to do with magnitude and stuff like that. So I'll come back to more information on that. But this is going to have to do then, if I'm talking about the magnitudes and we're talking about the angles, then it's probably going to be something with geometric. And then when I look here again, magnitude, here's the magnitude and an angle. So this would be geometric. So I'm not even solving yet. I just am trying to get you guys to see, like, I can tell kind of where I'm going to use based on the information I'm given. Let's see. Notation here. See that sub value? I see that, and I'm going to think right away that it must be my projection. So we'll talk again about it. But just looking at what they're giving me, I don't even know what anything else is or how to do any of it, but I can tell just from matching it up and looking at the information they're giving me on which method I'm going to use. So let's go ahead. Let's go through this first one. There's a lot of information here. I highly recommend you watch the video because I will touch base on some of the stuff that I feel like they didn't cover enough for you guys. So first thing, solving these, I think they did fine on just this basic stuff. So I'm going to go ahead, I'm going to multiply my U1 and V1 together. So my U dot V is going to be 5 times 2 plus I'm going to do my U2 times my V2. So it's going to be negative 7 times 1. So I have 10 minus 7, and it's just a value of 3. We're done. There's my solution. Perfect. This next one, this next one's going to be a little bit, this has some background information you guys need to know. So if I have the length of 2 vectors is 5 and 8, and they have a dot product equal to negative 20. Which is true about the vectors? Okay, so here's the thing. If my dot product is positive, then the vector is acute. It's going to be acute. This is negative. So if my dot product is negative, it's going to be obtuse. So acute. If I have all kinds of things. Okay, so here's where these two values come in. 5 times 8 is 40, right? So this is going to be the max value for my dot product. So they're the same direction if cosine of theta is equal to 1 and my 5 times 8 is equal to 40 is my max dot product value. So I would have to have the dot product to be that value, that max value. They're going to go in opposite directions when cosine of theta is equal to negative 1. So this would be then a negative 40. That's going to be the min value that this can be then. This would be my min dot product value. So that's all based on these lengths. So in this case, neither of them equal that. When I multiply the lengths together, my dot product doesn't equal that value. So they're not going to be going in the same direction or opposite directions. So opposites, they'd be negative, same. They're going the same direction. So pointing the same way versus opposite would be a positive. So in this case, since it's just a negative value here, it would be obtuse. So if it was positive dot product and not one of these two, then it would be acute. If it's going to be a negative and not one of these two scenarios, or this scenario, then it's going to be obtuse. So this is your summary on how to figure out the angles between the vectors. So again, we're talking about the angle between the vectors. So here's a vector, here's a vector. What is this angle in between? All right, kind of a lot of info there. So again, take notes on that, keep that handy. Geometric, how do I use it geometric? Well, here's my equation for geometric. This says that my dot product is going to be the magnitude of u times the magnitude of v cosine of theta. Well, fabulous. Magnitude of u is 8. Magnitude of v is 6. Cosine of theta is 40 degrees. Go to your calculator. Make sure you're in degrees. Plug it in. That's all you've got to do. And when I do that, I get 36.77. Answer, done. Again, biggest mistake, make sure your calculator is in degrees, because I don't know where you guys left it off at. So always check that. And I'm going to do our last type of problem for these dot product examples, and then I'm going to add a little bit more info to it. All right, so here's what I know. For my projection of x onto y, so if I'm looking, if I'm looking for my projection of x onto y, so the projection of x onto y is equal to the magnitude of x cosine of theta. So once I know that piece, then I'm going to do the dot product of xy is equal to the projection of x onto y times the magnitude of y. So I need to figure out this piece first, then I could go to this piece. Okay, what do I have? I have the vectors x and y have lengths 18 and 24. So again, magnitude of x is 18, magnitude of y is 24. That's what that's telling me. The lengths are the magnitudes. So that's what I know. The cosine of the angle between them is 5/9. Okay, so this says the cosine of the angle between them is 5/9. Cosine of the angle, so cosine of the angle is 5/9. So they're not telling you theta is 5/9. They're saying cosine of the angle between them is 5/9. So let's fill in everything we know. I need to find this projection, and it tells me it's going to be the magnitude. Sweet, I know that is 18 times cosine of theta. Oh, look, I know cosine of theta. They didn't give me just theta. I could plug in this whole piece. Cosine of theta was my 5/9. Oh, they made it even easier for me, right? And then I know 9 goes into 18 2 times, so 2 times 5 is 10. Awesome. That means when I go over here, this value of 10 is just this piece, times the magnitude of y, which we already said is 24. So it's going to be 240. Not too bad, right? Take it piece by piece. So my answer here was 10. This was going to be 240. All right. More information. What if they didn't tell me what cosine of theta was? So in this case, it was really nice because I knew what cosine theta was. They told me. I can find the angle between the two vectors. So this is another extra piece. I know that cosine of theta is equal to the dot product of u times v all over the magnitude of u times the magnitude of v. That means that if I want theta, then it's equal to, remember, if I want to solve for the angle, then we've got to use the inverse. So if I want just theta, then I would do cosine inverse of all of this. So it'd be cosine inverse of the dot product of u dot v all over the magnitude of u times the magnitude of v. Always a lot to take in. Formulas, these are formulas. Keep all your formulas together, keep them handy. These are things you need to know. You can't do these without the formulas. Vocabulary, orthogonal. Okay, so are vectors orthogonal or not? Those are going to be questions you're asked. How do I know if they're orthogonal? First off, I know they're orthogonal if the dot product is equal to 0. Okay, so I can figure out they're orthogonal. What does orthogonal mean, right? What am I even looking for? I've never heard this word. Orthogonal is just asking if they are perpendicular. That's it. Are the two vectors perpendicular? They're perpendicular if the dot product is equal to 0. So orthogonal just means perpendicular. All right, so let's look at this. You'll have several examples and it will just say like, are they orthogonal? Find the dot product. Again, if it's equal to 0, they are orthogonal. If it's anything else but 0, they are not orthogonal. They're not perpendicular. All right, so this one says, 2 vectors with magnitude 6 and 9 have a dot product equal to 27. Find the angle between them. All right, if I want the angle between them, here's what I want to know. I want to figure out what that theta value is. So theta is equal to cosine inverse of the dot product of them. Dot product was negative 27. I didn't even have to solve the dot product. All over the magnitudes, 1 is 6, 1 is 9. So 6 times my 9. I plug this in my calculator and I do cosine inverse of, I could choose to, well, actually, I would probably, so I would go to my calculator, make sure I'm in degrees. I'm in degrees. I would do cosine, shift cosine inverse, and I would do negative 27 divided by, I mean, you could, hopefully you know 6 times 9, but again, if it was numbers that you didn't know, if I'm going to put it all together, make sure you parentheses this quantity. So I would do my 6 times 9 all together. If you just do negative 27 divided by 6, it's going to take that value and then multiply it by 9. So you get the wrong answer. So be careful. And then I go ahead and I hit my equals, and I'm going to get the value of 120 degrees. So again, I would just do 6 times 9 in my head and plug it in. But if there are numbers like 53 times 27, something like that that you don't know, then make sure that you set it up like that. So kind of just practicing, making sure you know how to use your calculator correctly. All right. And then our last type of problems are our work problems. So there's 2 different types of work problems. Actually, you can always kind of default to this one. This is saying the vectors are in the same direction. So this is just going to be a value of 1. Remember, we said here if they're in the same direction, then that's just going to be a value of 1. So it's just not necessary. They're just saying that that would be a value of 1. If it's on the same direction, then you need to have cosine of that value. So how would I do a work problem? And there's a few of these throughout this section. So it says, consider a force is the vector -1, 3 applied to an object that is moving from my point here at 0, -9 to the origin. So I have a point that's moving. This is not a vector. Look at notation, parentheses versus our vector notation. And remember, it's always bold. So this is where I'm starting. This would be my initial, and this would be my end. So it's at the origin at 0, 0. So the first thing says, find the displacement vector of the object. So this is where my object starts and then it's moving to the origin. So it's going along my graph. So it wants to know what is that displacement. So it's going to be, to figure out the vectors, it's going to be, remember, 0 minus 3 and 0 minus a -9. So put it into your component. So the displacement vector is going to be -3, +9. A negative will make that a positive. So this is going to be -3, +9. That's going to be the value I'm using for my D. That's talking about from where I started to where I ended. Then I'm going to ask to find the work done in the moving object. And work always has the units of joules. So it's all usually there for you, but work is done in joules. So to figure this out, I need to know, are they going to move the same direction or different directions? So let me show you how I would look at this. So my question is, are they going to be in the same direction? All right. This is my force, and this is my displacement. If I look there, I can see that there is a correlation, right? I could see the correlation. What do I mean by that? If D is equal to, my displacement here is equal to 3 times my F. So it's just, if it's going to be some value, if I can multiply this by 2, by 5, then they're going to be moving in the same direction. So this would show something that's going to be the same direction because they both have that same constant. So one was multiplied by a 3 and the other was a 2. That's not the same direction because it's got to go, it's not a constant. So it's got to have this scalar factor out in front for it to be moving in the same direction. Tomorrow or the next day, I have an example where it's not the same direction. So don't worry, I will show you. But this is just easy for you guys to identify. So again, it was 3 times my -1,3. My force was equal to my D, which is -3,9. So they had that same scalar factor. So it is going to be the same direction. If that's the case, then it's just FD, my dot product. So it's going to be -1 times -3, plus 3 times my 9. If I had the magnitudes of them, then I would use that. I don't need to. Equals 3 plus 27 is equal to 30 joules. So again, I can easily figure out, since I know F and D, I could just do their dot products. If I knew the magnitudes, then I could worry about the same direction, but we do some of this stuff. So I just kind of want to point out, how do you know if they're the same direction? So you can use either one of these, just depends on what information you're given. In this case, it's going to be 30 joules. But for it to be the same direction, it has to have a constant between the two vectors. Tomorrow we'll go into assignment. Actually, not tomorrow. You guys have a great weekend. This is your Friday. So we'll go over problems on Monday from the assignment, and I'll cover some more stuff in depth. So otherwise, you guys have a fabulous weekend, and I will see you guys Monday. Take care.